Hey everyone, and welcome back to the channel. Have you ever looked up at the night sky, seen that bright, beautiful moon, and wondered what's really up there? We often think of it as a barren, dusty rock, a silent companion on our journey through space. But what if I told you that silent companion might hold the key to humanity's future? What if the moon isn't just a pretty sight, but a treasure chest of unimaginable wealth, waiting to be unlocked? Today, we're diving deep into a question that sounds like science fiction, but is rapidly becoming science fact. What's hiding on the moon, and will we be mining it by 2050? Let's start here on Earth. Our world is incredible, but it's not infinite. We're facing a growing challenge, the scarcity of critical resources. Think about the device you're watching this on right now. Your phone, your laptop, your tablet, they all rely on a cocktail of special materials known as rare earth elements. Things like neodymium, yttrium, and lanthanum. They're essential for everything from powerful magnets in electric vehicles and wind turbines to the vibrant colors on your screen. The problem? Over 90% of the world's supply is controlled by a handful of countries, making global supply chains incredibly fragile. As our technology advances and our population grows, the demand for these elements is skyrocketing, and we're starting to realize that Earth's reserves just might not be enough. This isn't just an economic issue. It's a fundamental challenge to our continued technological progress. We need a new source, and that's forcing us to look up. For decades, the moon has been the subject of scientific curiosity. The Apollo missions brought back rocks and dust, giving us our first real taste of lunar geology. And what we found was tantalizing. But the riches don't stop there. Remember those rare earth elements we talked about? While they're rare on Earth, evidence suggests they might be more accessible on the moon. Asteroid impacts over eons have pulverized the lunar surface, and some of these asteroids were rich in metals. It's possible that concentrations of platinum, palladium, and other valuable elements are just sitting on or near the surface, mixed in with the lunar regolith. That's the official term for moon dust. This isn't just about making more smartphones. These materials are vital for green technologies, advanced medical equipment, and aerospace engineering. Securing a steady, accessible supply from the moon could trigger a new industrial revolution. And perhaps the most critical resource of all, the one that makes everything else possible, is water. For a long time we thought the moon was bone dry. But recent missions, like NASA's Cross probe, which deliberately crashed into a crater near the lunar South Pole, confirmed the presence of significant amounts of water ice hidden in permanently shadowed craters. These are areas that haven't seen sunlight in billions of years, making them cold enough to preserve ice. Water on the moon is a complete game changer. It's not just for astronauts to drink. Through a process called electrolysis, we can split water molecules H2O into hydrogen and oxygen. Oxygen is breathable air, obviously crucial for a lunar base. And hydrogen and oxygen are the primary components of rocket fuel. This means the moon could become a cosmic gas station. Instead of having to launch everything we need from Earth, fighting against our planet's massive gravity, we could refuel spacecraft on the moon for missions deeper into the solar system, to Mars and beyond. The presence of water transforms the moon from a mere destination into a launchpad to the stars. So, the potential is undeniable. The moon has the energy, the materials, and the fuel to revolutionize our future. But this brings us to the core question. Is mining the moon by 2050 a distant dream, or is it an inevitable reality? Let's break down the hurdles. First, the cost. Getting to the moon is still incredibly expensive. Developing the robotic miners, the processing plants, the transportation systems, we're talking about an investment of hundreds of billions, if not trillions, of dollars. It's a monumental undertaking that no single company or even country might be able to afford on its own. Then there's the technology. We've landed people on the moon, sure, but living and working there for extended periods is another story. The lunar environment is harsh. There's no atmosphere to protect against radiation or micrometeoroids. The temperature swings are extreme, from scorching hot in the sunlight to unbelievably cold in the dark. And the lunar dust is a major problem. It's not like beach sand. It's sharp, abrasive, and electrostatically charged, so it sticks to everything. It can damage equipment, clog seals, and pose a serious health risk to astronauts. We need to develop new technologies for habitats, life support, and rovers that can withstand these conditions for years on end. We'll need robots that can operate autonomously or with minimal human supervision to do the heavy lifting and dangerous work of mining. And finally, there's the legal and ethical framework. Who owns the moon? The Outer Space Treaty of 1967, which is the foundation of space law, says that celestial bodies are not subject to national appropriation. In other words, no country can plant a flag and claim a piece of the moon. But the treaty is silent on the issue of private companies extracting resources. This has created a legal gray area. More recently, initiatives like the Artemis Accords, led by the United States, are trying to establish principles for cooperation and resource extraction. But not all major spacefaring nations, like China and Russia, have signed on. We need to answer some tough questions. How do we ensure that lunar resources benefit all of humanity, not just a wealthy few? How do we prevent a chaotic gold rush in space that could lead to conflict? And what about protecting the lunar environment itself? Some areas of the moon are of immense scientific and historical value, like the Apollo landing sites. How do we balance economic interests with preservation? These are complex issues with no easy answers. Despite these challenges, the momentum is undeniably building. You just have to look at who's involved. NASA's Artemis program is in full swing, with the goal of establishing a sustainable human presence on the moon. But it's not just NASA. Private companies like SpaceX, Blue Origin, and a host of smaller startups are developing the rockets, landers, and technologies that will form the backbone of a future lunar economy. China has its own ambitious lunar program, including plans for an international lunar research station in partnership with Russia. India, Japan, and the European Space Agency are all in the game too. This isn't a single space race like in the 1960s. It's a global, multifaceted push towards the moon, driven by both national prestige and powerful commercial incentives. So, let's look at the timeline. By 2030, we can expect to see regular crewed missions back to the moon, establishing the first long-term habitats and research outposts, likely near the water ice-rich South Pole. These early missions will be focused on prospecting using rovers and drills to map out the most valuable resource deposits. Think of it as the survey phase. Then, from 2030 to 2040, we'll likely see the deployment of pilot projects. Small-scale robotic miners will test extraction and processing techniques. They might start by demonstrating the ability to extract water and turn it into rocket fuel, proving the cosmic gas station concept is viable. This is the proof of concept decade. If those pilot programs are successful, then the period from 2040 to 2050 could be when we see the beginning of commercial-scale operations. Imagine fleets of autonomous robots scooping up lunar regolith, feeding it into processing plants that separate out the valuable materials. Large cargo landers would transport refined resources, like helium-3, rare earths, or water into lunar orbit, where they can be used to fuel deep space missions or even be sent back to Earth. It won't be a massive, sprawling industrial complex overnight. It will start small and grow incrementally. But by 2050, it is entirely plausible that the first shipments of lunar resources will have reached Earth, kicking off a new era of human civilization, the era of the space economy. So, is moon mining by 2050 an inevitable reality? Looking at the convergence of resource scarcity on Earth, rapid technological advancement, and the immense economic and strategic incentives, the answer leans heavily towards yes. The path is filled with immense challenges, technical, financial, and legal. But human ingenuity has a remarkable track record of overcoming such obstacles when the motivation is strong enough. The allure of lunar riches is a powerful motivator. The moon isn't just a rock in our sky anymore. It's a new continent, a new frontier, holding resources that could solve some of our biggest problems on Earth and fuel our journey to the stars. The next 30 years will be some of the most exciting in human history as we take our first real steps to becoming a multiplanetary species. What do you think? Is this the future we're heading for, or is it all just a pipe dream? Let me know your thoughts down in the comments. I'd love to hear what you have to say. Thanks so much for watching, and if you enjoyed this journey to the moon and back, don't forget to hit that like button and subscribe for more deep dives into the future of science and technology. See you next time.